points. One of 3 quizzes that we'll take. You guys know this is the toughest unit we have had all year, which probably means the toughest quizzes we've had all year. 3 formulas to know tomorrow. One is going to be on the formula sheet I provide you, which is circumference, pi d. D is for diameter length. That is on the formula sheet for you tomorrow. There's a lot on circumference. Next 2 formulas deal with length of an arc, which are not on the formula sheet. Okay, length of an arc, 2 formulas. First formula is if your angle is in degrees, and I've already shown you these 2, but let's review them again. All right, if your angle is in degrees, I do the measure of the arc over 360 times the circumference, pi d. That's if my angle is in degrees, If it's in radians, we went over this on Friday. If it's in radians, I use SOR. S for arc length equals theta, which is your angle in radians, times r, radius length. So again, I told you in the homework, you want to memorize one of them, you can get away with that. All right, and nobody's going to be, I'm not going to be upset. You can just get away with knowing one formula, but no, you have to be in a certain measure to use that formula and be able to convert on your calculator. So you just want to memorize SOR, you can get away with that. That's fine. But just remember, everything's got to be in radians. So I give you a problem in degrees, you got to convert that sucker on your calculator, then plug it into theta. Your call, though. Memorize both or one. Sorry, I forgot the I over here. One job. Know what a semicircle is, a major arc, and a minor arc. Know the difference between the 3. And how to find the measure. This was length of an arc, how to find how long it is, how to find the measure. Quick example, probably not going to be this easy, but let's say that's the center. That's 60 degrees right there, my central angle, 60 degrees. And I want to find what's this arc measure right there. Put some letters on here, huh? A, B. I'll put a C there. So I'm looking for the measure of arc ACB, not the arc length, guys. So nothing to do with the formula, just how many degrees are in that arc. If that's 60, so is the arc measure, right? But I'm looking for the other one. So 360 minus that. So 300 degrees. So that's what we're looking for on the quiz tomorrow. Can you go to page 16 in your packet real quick? 16. Look at the bottom of today's notes, please. On page 16, look at the bottom of today's notes. I really want you to focus on this quiz and be successful, all right, because it's going to be a tough one. So notice tonight's homework, that page 727 is not due until Wednesday. Okay, it will not be, I will not check it. I will not ask questions about it until Wednesday. It is not part of the quiz. I want you to focus on the quiz tomorrow. And that's why you got a Delta math. All right, there's a Delta math to prepare. All right, so everybody good? I really don't want you to even look at page 727 tonight. It has nothing to do with the quiz. I want it due by Wednesday, though. All right, I want you to focus on the Delta math. Anything about the quiz you want to ask, and I am available after school today if you want to come by and do the Delta math here with me, or just ask any questions in general. I'll be here after school. We're all right, going? Okay. So you guys are all set for the quiz tomorrow. I'm moving on, though, in the packet to day 4. I know it says 7 up there, but we're going to be day 4. New type of angle. First question I have from somebody is kind of like a review for the quiz. That dot's the center, all right? If anybody's confused, you don't have to draw this in either. All right, what type of angle did I just draw in there? What type of angle did I just draw up there inside the circle going into tomorrow's quiz? What do we call that type of angle in a circle? What's that angle called? Here we go. Makai, remember what that angle's called? That's a central angle. Good job. That's called the central angle. And it was always equal to, how do I find a central angle? Always equal to its arc measure, right? Those two went together. Here's what I want you to do. Can you put a point on the circle for me, please? Anywhere on the circle. All right, I've given you in your notes right there. Put a point on the circle. Anywhere on the circle, please put a point. From that point, draw 2 chords, please. From that point, draw 2 chords in the circle. Coming from that point. 2 chords. So hopefully you've made an angle. Huh? You made a new angle in the circle. All right, I don't care if it went through the center or not. Need 2 chords. 2 chords, please, coming from the same point. I don't care if it goes through the center and forms a diameter. It doesn't bother me. I'll do one here too. All right. That's not a central angle though, right? That's not a central angle. We got a new name for it now. If the vertex is on the circle, we're going to call it an inscribed angle now. Okay, so now you have a central angle, which comes from the center. And now today I'm going to introduce an inscribed angle. All right, which the vertex is on the circle. All right, inscribed angle. The vertex is on the circle. All right, so this is an example of an inscribed angle. Next, how do you find the measure of it? Because it's not like a central. If that's 60, that's 60. No, it doesn't work that way. That's for central angles only. How does an inscribed angle work? Here we go. First theorem of today, an inscribed angle. It's not equal to its arc. It's not a central angle. It's not equal to its arc. Instead, ready? Half. It's half, though. It's half the measure of the connected arc. That's how inscribed angles work. Half the measure. So on my diagram, let's say that arc's 100, my inscribed angle, 50. That's how it works, okay? All good? That's how you find an inscribed angle. You take half its connected arc. That's how it works. The angle is always half of the arc. All right, let's hop right into some questions here. Boom! I got triangle ABC. You guys can, everything's already drawn in. You're welcome for you. All the angles are plopped in. All right, first up, let's find the measure of arc BC. That's what the M stands for, measure of arc BC. Now look, I'm talking about measure. I don't need SOR or any formula. I'm looking for how many degrees when I ask for measure. What's that 80 up there? What's that angle called again that I labeled 80, angle A? What do we call that angle again? That's A. What do we call that? Simon, what do we call that angle? That 80 degrees, angle A. What do we just refer to it as? Inscribed angle. It's always equal to half the arc it's drawn to, right? Oh! Look what arc it's drawn to. The one we're trying to find. So whatever arc BC was, I took half of it and got 80. See how the inscribed angle works here. Whatever arc BC was, I took half of it and got 80. So what do I need to do to the 80 then to get the arc? What do you want me to do with that 80 degrees to get to the arc here? Flying around here. There we go, Lily. There you go. I want to double it. So 80 times 2, arc BC, 160 degrees, because it's coming to an inscribed angle. Hey, why don't you label your diagram too? You may need that 160 in a later part of the problem. Questions on why the buck's 60? All right, let's keep grooving. Angle B. Angle B. Now, looking for angle B. All right, identify it. What type of angle? Because, hey, we have 2 types of angles now, central and inscribed. I got to know what type of angle B is. Stephanie, what type of angle is angle B? Inscribed. Great job. So I know my rule. Take half the arc it's drawn to. What's the arc measure it's drawn to here? Stephanie, on again. Fire. Angle B is drawn to what arc? Which is how many degrees? So there you go. Based on what you just told me, I'm going to take half of 88. And that's going to give me a 44 degree angle. So angle B, 44. All right, angle C now. Angle C. And I want it. You don't always have to use a circle pad. You're going to hear me say this a lot now that we're getting to this point of different angles in a circle. Whatever gets the job done. I'm not always looking for a circle fact. And I say that because you don't have to use a circle fact here if you don't want to. How are you getting angle C? Talk to me. Oh, Stephanie, 3 in a row. Can we believe that, everybody? Unbelievable. What do you got? You don't have to use a circle fact. There's 180 degrees in a triangle. I can subtract that from 44 and 80. Boy, that's 100. What are we looking at there? 46? No, 56. That's 56 degrees. And then part D, what's the measure of arc AB? We are going to have to use a circle fact here, but you could use a couple circle facts that you know of. How to get arc AB. Here we go. Oh, thought we were going to do a 4-bagger here. We'll just have to settle with Cormac, though. What's your go-to for this?
Add 88 to 160.
Yep. That's one way. There's 360 degrees in a circle, so subtract those two. Or you could also double 56 if anybody wanted to do that. Whatever floats your boat. And that'll give me, let's see here, if I double 56, that's probably easier for me in my head. 112. 112 degrees. Questions using these newfound inscribed angles. All right, let's keep using them. Let's keep grinding away. I'll let you guys do these two on your own. Find ADB and ACB in that diagram. It looks like both of them are inscribed angles. What'd you find out about those two angles? What'd you find out when you found the value of each of them? Zoli, what'd you find out? Yeah, they ended up being congruent to each other, didn't they? Because you took a half of 124 to find the one, and you took a half of 124 to find the other to get 62 degrees for both. You just proved my next theorem. All right, here we go. What type of angles were both of those again? They were both inscribed. So ready, let's start up. You guys are going to write the fact for me. Inscribed angles. Where were both of those inscribed angles drawn to? Or connected to? The same arc, weren't they? So inscribed angles drawn to the same arc. And would we figure out about them again, Zoli? Arc congruent. Okay, so anytime we have two inscribed angles that end up at the same arc, they got to be equal to each other. Got to be. All right, try out example 3 now. Using that fact, try out example 3. You're finding the arc here, not the angle. You're finding the arc, though. ABD, 6x plus 26. ACD. Notice that they're both inscribed angles drawn to arc AD. They're both drawn to the same arc, so that means they're equal. But I'm interested to see, once you find X, what do you do with it to get to arc AD? Oh, it is heating up in here temperature-wise. Love it. Keep raising the temperature. Keep it up. All right, I can get to x equals 5. I can do that on my own. How'd you get to AD, though? Arc AD. I wasn't looking for the angle, but how'd you use x equals 5 to find the measure of the arc? Talk to me. Explain to me here. There we go. Lily, over to you again.
So I put in 5 for x.
Which one did you use?
A, B, D.
So you did the 6x plus 26?
Yeah.
All right, so I take 6 times 5 plus 26. Got that. And then that's the angle. That's the inscribed angle. How'd you make it into arc AC?
Multiplied by 2.
Great job. Yep. Times that by 2 to get to the arc. Great work. 30, 56, buck 12. Good. Any issues? Yes, more inscribed angle stuff. I know you're hungry today. Let's go. Maybe you didn't get to that breakfast. I'll keep feeding you. How about this diagram? How intimidating does this beast look, huh? Wow, a lot of lines all over the place. All right, so we are responsible for X, Y, and then the measure of arc BC. Don't gloss over this. It's important. AB is a diameter. All right, AB is a diameter. That's going to be important to us, so don't gloss over that. All right, let's start with X. Why not? Let's start with X. How many degrees are in angle X? All right, well, first I'd like to know what type of angle is angle X. Look at it. What type of angle? One we've been talking about, I think, here today. Tess, what type of angle? Inscribed, right? Yeah, it's inscribed. So I know it's going to be half. Take a look. It's going to be half of the arc it's drawn to. Can you guys find that arc it's drawn to? Follow angle X out. And take a look. Isn't angle X connected to that arc right there? That's what angle X is connected to. Good review for tomorrow's quiz. What type of arc did I just highlight? Remember, this is why we needed to know AB was a diameter. What type of arc did I just highlight there? Whoa, one zip. Henry, what type of arc did I highlight? Yeah, that's a semicircle. And we know it's a half circle. So that's got to have 180 degrees. Looks like a half of 180. Everywhere. See, it's drawn to the semicircle. Semicircles are 180. Oh, so that means angle X is going to be a right angle, huh? 90? Yeah, that's a right angle right there. And I'll stop you. Everybody stop. It's already written in there for you. We don't have to write it, but take a look at the next theorem here. Anytime we have an inscribed angle that's drawn to a semicircle, we don't even need to do any work. It's automatically a right angle. Okay? Anytime a inscribed angle drawn to a semicircle, it's always got to be a right angle. Always. No other degree measure, always a right angle. All right, let's go to angle Y now. Angle Y. Sometimes you just don't need a circle fact. All right, how are we getting to angle Y? Woo. There we go. Cormac, back to you. How you getting angle Y?
50 plus 90, and then subtract from
Yeah, just use your triangle fact there. 180 minus the 90 minus the 58. Oh, stretching my human calculator limits here today. Let's see, I got to borrow from the 9, like they teach in elementary school, right? Add a 10 over, that's 2. But I borrowed that already. 32. Took me much longer than I needed to. 32. And finally, one more. Find the measure of arc BC for me. Arc BC, measure of arc BC. And we just found that angle A was 32 degrees. Got it? Measure of arc BC. How can I find the measure of arc BC? All right, how'd you get to it? I can help you too if you need to. Vinny, how you getting to it?
Multiply y by 2.
32 degrees we just found. That's inscribed. Look where it was drawn. The 32 is drawn to arc BC. So I'm going to double that inscribed angle to get to the arc. 64. All right, anything before I show you the third and final fact for today? So the first fact was inscribed angles. Actually, first fact was 2 inscribed angles drawn to the same arc are congruent. Fact number 2, if it's drawn to a semicircle, it's a right angle. Final fact today, you guys are going to draw your own diagram here. Let me see those beautiful circles right underneath this theorem, this second theorem. Oh boy, freehanding a circle. I said a circle, not an oval, some of you. You might as well just put your pen in your mouth and draw this. It's going to be the same looking circle. Okay, inside the circle, put a quadrilateral. But the 4 vertices have to be touching the circle. Okay, so plop a quadrilateral in there for me. I don't care what it is. Any 4-sided figure, put it in. Make sure the vertices are touching. Call that quadrilateral ABCD. Make sure you go clockwise or counterclockwise when labeling. And here's where the final theorem fact says, if you have this diagram, a quadrilateral inside a circle, the opposite angles supplementary. So they add 2, a little quick review of that. 180. So this would mean angle A plus angle C equals 180. And separately, angle B and D add up to 180. All right, only if you have a quadrilateral inside a circle, they add up to 180. All right, knowing that, try to figure out that last problem for me. This is kind of a whole review of today's notes, this last problem. See if you can answer those 2 questions. Find arc GFE, and then find angle F. And it's the opposite angles at 180, not opposite arcs, the opposite angles. GFE. Let's start with arc GFE. This one right here. What is the measure? Measure. So I'm looking for degrees, not length. Measure of that arc, GFE. How'd you go about it here? Going back, Lily? On fire today. What'd you do?
86 times 2.
Good. Lily said, hey, 86 is inscribed. Hey, look, it's drawn, connected to that arc we're looking for. So I got to double it. 86 times 2, 172. Good job, Lily. Good work. And then how about angle F? How do we find angle F? Whoa, there it is. Jonathan, how do we find angle F?
It's opposite from D, so it'd be 86.
It's got to be supplement,
Oh,
not congruent.
yeah, sorry, I'm supplementary.
So what do I want to do with the 86? It's not 86. What do I have to do with the 86?
Take 180 and subtract it by 86.
There you go. 94. Okay. One last time. This homework's not due until Wednesday. All right. I prefer you try out the Delta Math, which you can get out right now. So you can get out your Chromebooks. And I'll be after school today if you want to review anything.